Hi. So for part B of this question, we're told the line with equation y equals kx, where k is a constant, cuts C at two distinct points. And we're asked to find the range of values for k. Okay? So this is a 6-mark question, so there will be quite a lot of working out. And if you by happen to get an answer with 1 or 2 lines of working out, you're probably on the wrong track. Okay? That's why it's a good idea to have a look at the marks for every question that you do. Okay, so we know from part A the equation of the circle. Okay, so I've just congregated the x terms and congregated the y terms. Okay, so I've just reordered a few of the terms just to make it easier for myself in the future. And I haven't used the equation in the form x minus a squared plus y minus b squared equals r squared, just because it will make a little bit of less working out. If you use that equation, the equation in the other form, it's completely fine. You will get exactly the same answer. I've just opted for this, the equation in this form. Okay, and I've got the equation of the line here. Okay, so what I'm going to do is I'm going to call equation of the circle number 1, equation of the line equation 2, and what we're going to do is we're going to substitute 2 into 1. Okay, so we're going to just pretend as if we're solving these two simultaneously. Okay, because we're told that the line crosses the circle at 2 distinct points. Okay, so we're just going to act as if we're solving this simultaneously by substituting equation 2 into equation 1. Okay, then we'll have one long equation just in terms of x and k. Okay, from this long quadratic equation that we're going to get, okay, so we've eliminated the y's, so it's just going to be x's and k's. It will be impossible to solve for x and k. We have one equation with 2 variables, we won't be able to find both of them. But this is extremely important here. We know that the line cuts C at 2 distinct points. So that long quadratic equation is going to have 2 real solutions. Okay, so we can evaluate the discriminant. Okay, this is a new topic for new spec. It's kind of a new kind of questions that they've been asking. If the line was to cut the circle at 1 point, that long equation that we're going to generate right now will only have one solution. Okay, and if they don't intersect, it's going to have no solutions. Okay, so you can evaluate the discriminant differently in each of those different scenarios. Okay, so what I'm going to do now is I can therefore say x squared minus 6x plus y squared, and I know that y is kx. Okay, plus 10y, and again y is kx, plus 9 equals 0. Okay, now I'm just going to expand out those brackets so I can say x squared minus 6x plus k squared x squared plus 10kx plus 9 equals 0. Okay, so as I said before, I'm going to have a nice long quadratic just in terms of x and k. Okay, so what I'm going to do now is I'm going to congregate the x squared terms together. Okay, so we've got x squared. I'm just going to move everything, shift everything along, plus k squared x squared. Okay, so I want the x squareds together, plus 10kx minus 6x. So I've just reordered the terms. Plus 9 equals 0. Okay, so we have a quadratic equation here. Just to help see what the coefficients a, b, and c are, I'm going to factorize out x squared and factorize out x. Okay, so I'm going to factorize out x squared from this first part. So x times 1 is x squared, and then x times k squared gives us k squared x squared. Okay, plus, and again, now I'm going to factorize out the x. So we're going to have 10k, x times 10k is 10kx. And now x times by minus 6 will give us that minus 6x there. Okay, plus 9 equals 0. Okay, this is very important here because now it makes my coefficients a, b, and c much more easier to spot. Okay, so I know straight away now that a, which is a coefficient of the x squared term, is just 1 plus k squared. And b, which is a coefficient of the x term, is just 10k minus 6. And then c is 9. Okay, so because we know the line cuts the circle at 2 distinct points, we can say line cuts the circle at 2 points Therefore, the equation has two real roots. Okay, so therefore, the equation has two real roots. Okay, so we can therefore say, evaluating the discriminant, that b squared minus 4ac is greater than 0. Okay, so now we can just simply substitute our values of b and a and c in, and now you'll see why this step was so important, why I factorized at this point, because now I know that b is just 10k minus 6, 10k minus 6 squared minus 4 multiplied by a, which is 1 plus k squared, times by c, which is 9. Okay, and this is all greater than 0. Okay, so I think I should be okay squeezing this next part down here. I'm just going to expand this bracket. Okay, so I'm going to do it nice and slowly in steps. 10k minus 6, 10k minus 6. And I really recommend you to do this when you're working under pressure, especially in an exam, not to skip out too many steps. Okay, so what I'm going to do here is I'm just going to do 9 times the minus 4. So we have minus 36, 1 plus k squared is greater than 0. Okay, so now I'm going to start up here again. We can therefore say, so on the next line I'm going to expand this bracket here. 10k times by 10k is 100k squared. 10k times minus 6 is minus 60k. Minus 6 times 10k is minus 60k. Minus 60k minus 60k is minus 120k. Just going to do that again. It doesn't look like a 6. And then minus 6 times by minus 6 is positive 36. Okay, now minus 36 times by 1 is minus 36. Minus 36 times by k squared is minus 36 k squared. And this is all greater than 0. Okay, so I can just simplify at this point. 100k squared minus 36k squared is 64k squared. 36 minus 36 is 0, and we have minus 120k. Okay, keep drawing my zeros like 6s, and this is great. Sorry, this is 120k, and this is greater than 0. Okay, so now factorize again. I can pull out 8k. 8k times by 8k is 64k squared. Minus 15. 8k times by 15 is minus 120k, and this is all greater than 0. I get a lot of questions from students asking, when should I factorize? You know, I see you factorizing a lot. My general rule of thumb, always factorize. If you can factorize something, factorize it. It will, like 99% of the time, make your life easier. Only very few situations would you not opt to factorize. Factorizing is usually always the best thing to do in any scenario. Okay, so now we have a quadratic inequality. We want to see where this is greater than 0. Do not just say 8k is greater than 0 and then 8k minus 15 is greater than 0, like the first time I did it. Even the pros make mistakes. This is a quadratic inequality. We want to see where this graph, we can sketch this actually, and I can show you here. So 64k squared minus 120k looks like this. Okay, we have a solution at 0 and at 15 over 8. We have a root at 0 and a root at 15 over 8. And we want to see where this is greater than 0. Okay, so where is this greater than 0? Where are the y values greater than 0 if we assume k is a function of y? It's going to be here and here. Okay, so you should always sketch a graph whenever you have a quadratic inequality. From this, we can now say that we've got, therefore, k must be less than 0 and k must be, well, we can say or k must be greater than 15 over 8, that value there. Okay. Okay, so that's our range of values for k. So if you're having trouble with any of the topics in this video, coordinate geometry, equations of circles, or quadratic inequalities, do have a look at the links below in the description. And don't forget to like, comment, and subscribe, and let me know any other papers you want to see me do. But for now, thank you very much, and I'll see you in the next question.